Scatter graph have a two variable, which is variable x as a weight in a kg and variable y as a time in a minutes. Next, you need to give scalar for variable x and y, then insert all table information in a graph. After that, draw one straight line that make a balance on the right side and left side. The correlation between the time taken and the weight of the runner is a positive correlation. This is because the point is very close to the line of the best fit. This graph has a strong positive correlation. The relationship between weight and the time is increased. This is because the time taken to run 55 km is greater than for the heavy runner. 14 kg is beyond the range of data. The data suggests that the lighter you are, the quicker you are. There has to be limit. Taking this to a ridiculous extreme, a person could practically starve themselves to death, but this would not likely make them a fast runner.
Greetings, doctor and my fellow friends. My name is THONG WEI YONG and my matrix number is 279932. Today, I will show a sample of case study related to regression equation. My case study is as below. A test is designed to measure the relationship of age with the average blood concentration of LDL cholesterol in Canada citizens in 2013. Table below shows the data obtained from study with a variable of age and LDL cholesterol concentration. Given that the data above have a regression equation of y hat equal to 2.47 plus 0.01x, find the value of SSE for the data. The formula for calculating SSE is SSE equal to sum of E squared, where E is equal to y minus y hat. So in order to calculate SSE, we first need to create a table that looks like this, with age, where age as the x variable and blood LDL cholesterol concentration as your y variable, while for the y hat is basically the value of y estimated from the regression equation. So in order to obtain the value of y hat of each row, you need to substitute the value of x for the respective row inside the regression equation, which is y hat equal to 2.47 plus 0.01x to obtain the value of y hat of each row. After that, you need to find the value of E, where E is equal to value of y minus value of y hat of the same row. After you find the value of E, you need to find the value of E squared of each row, where basically E squared is just E powered by 2. After you find all the value of E squared, you need to sum up all the value of E squared in order to find the sum of E squared. And the sum of E squared will be the value of your SSE. So from the table, we know that sum of E squared is equal to 0.0334. So the value of SSE for the table or the data in the case study is SSE equal to 0.0334. And that's all from me today. Thank you very much.
Hi, I'm Cheng Jia Ying. Let's let's look at this question. A random sample of 8 workers who drive their own vehicles to work are selected from a company. Table below shows the list of distance from their house to office and the time taken for them to reach company. From this table, we can see that there are total 8 different workers with different distance and different time taken. So the independent variable x is the distance, while the dependent variable y is the time taken. So this table is given, the total x is 40, while the total value of y is 116. Let's look at question A. Given the value of x, syy, and xsy are 48, 410, and 134 respectively, find the regression equation for the data. Since we know that the regression equation is written as y equals to b0 plus b1x. So we can find the value of b1 using the formula b1 equals to sxy divided by sxx. So we can just substitute the value, which is 134 divided by 48. So we can get the value of b1 is 2.792. Then we find the value of b0 using the formula b0 equals to 1 divided by n times total y minus b1 total x. So from the previous table, we can know that the total value of n is 8 because there are total 8 workers, and the total value of x is 40 while the total value of y is 116. So we just substitute the value 1 divided by 8 times total y is 116 minus 2.792 times total x 40. So we can find the value of b0 is 0.542. So the regression equation is y equals to 0.542 plus 2.792x. Question B. Predict the time taken for a worker who drives his own vehicle to work and live 8 kilometers from his house to office. So we can predict the time taken by using the regression equation we obtained in question A, which is y equals to 0.542 plus 2.792x. So from the question we can know that the value of x is 8 kilometers, so we just substitute the value of x in the equation. 0.542 plus 2.792 times 8. So the time taken is 22.878 minutes for the worker who lives 8 kilometers from his house to office.
Good afternoon, sir and my fellow friend. My name is LIM WENG JOE and my matrix number is 278825. Let's look at this question. The relation between the age of a car and the yearly repair cost should be analyzed. For this, the following first data set has been collected with a variable of age and repair cost. Calculate the corresponding coefficient of determination R squared. Given that the regression line y equals to 18.0882x minus 32.6174. The formula of R squared equals to SSR over SST. SSR equals to sum of y at minus y mean whole thing squared, and SST equals to sum of y minus y mean whole thing squared. To find R, we need to construct a table with h as a variable x, repair cost as variable y, and the third column and the fourth column is to calculate SST, which is y minus y mean and y minus y mean whole thing squared, and the y mean equals to a total number of mean over n. That is 470 over 5, then we will get 94. For the fifth column under the 7th column, that we should find SSR. There is y at, then y at minus y mean and y at minus y mean whole thing squared. And then to find y at, we need to substitute variable x into the regression line. The regression line is 18.0882x minus 32.6174, and we substitute x into the variable 2. That is 18.0882 substitute and 32.4. Then we will get 3.559. It is the first y at. After that, we need to sum out the y minus y min whole thing squared, that is 23920, and y at minus y min squared, that is 2248.44. So we can find the R squared. The number of SSR is 2248.44, and the number of SST is 23920. So we can get 0.9301. Therefore, 93.01% of the variance of the repair cost can be explained via the regressions line.
Hello and good afternoon to our lecturer and other students that's in this video. So today I want to do the case study question about linear correlation coefficient. So let's start for the first question. So the following table show that the data from 6 girls of their age and weight. So this table from this question. So I already calculate the total of age and the total of weight. So 30 and weight is 136.2 kilogram. So before we calculate, let's start with the formula for linear correlation coefficient. So both of these are formula for linear correlation coefficient. So this is computing formula and this is simple formula. So in this video I will use the simple formula, which is, so using this formula you need to calculate SXY, SXX and XYY. So for the firstly, I make a table to calculate. So this is the table, so I add additional table, so I calculate XY, X square and Y square. So age, I thinking about X and weight is Y. So just calculate 4 multiplied with 16.6, we get 68.4. So same goes with other tables. And then don't forget to calculate the total of this. Then use the formula and calculate one by one. So SXY equal all XY total minus all X and all Y divide with N. N is all these 6 girls. This is N. So when calculate, you get the answer 22.4. So calculate the others and you get the answer 4 and 192.08. So and then use the formula, put this into the formula and you will get, so put this to the formula and you will get the answer. So answer is 0.801081. So it's close to 1. So it means a strong linear relationship. So it means it's close to 1. It means it's linear correlation relationship. So that's all from me.